Reference angles. So we know that reference angles do a couple of things. So the reference angles, if we look at them, they're always going to be off the x-axis. They're going to form, oops, that's a really bad one. They are going to form a bow tie, and they're always going to be 90 degrees to the x-axis, never the y-axis. And so they're all going to be mirror images of each other. So I could fold them this way, I could fold it that way. Whichever way I fold them, they're always going to be the same. So if this here is 30, then this one here is 30, this is 30, and that is 30. Very good. So those are reference angles on there, and they're going to help us do a lot. I know we saw that in the last video, and so we are going to get rid of that. And so this one here says determine the reference angle of 120 degrees. So 120 degrees, well, 120 is the standard position angle where we start, we're going to start here. We always start this ray right there, and then we're going to rotate it, and now it's going to be right here. So this here is going to be 120 degrees. From that 120 degrees, what is the reference angle? So then that's when we drop that down, form a right angle there, and then the angle made here is going to be, we know this is going to be 180, so we do 180 minus 120, and that gives us 60 degrees. So anything in this first quadrant is going to be 180 minus whatever that questionable angle is going to be. That's what we're going to do. If we're going this way and we want to find an angle in the third quadrant, it's always going to be 180 plus the angle in the third quadrant. And then when we want to find the reference angle in the fourth quadrant, we're always going to do this one here is 360 because these are always off the x-axis, never the y-axis. We're never going to use the y-axis to find a reference angle. So this one here is always in the fourth quadrant. It's going to be 360 minus the standard position angle. And so that's how we get the reference angle. So determine the reference angle from 120. We know that the reference angle is going to equal 60 degrees. Then it says here, determine the reference angle of 315. Well, we know that this here is going to be going clockwise. That's the direction, and the angle is 315 degrees. So a standard position angle, we are going to take this ray, and we're starting here at 0 degrees, and then we're going to rotate it to right there. And so standard position angle is going to be, this one here is going to be 315 degrees. We're going in the negative direction, so it's negative 315. Now the reference angle that we're going to do is going to be drop this down, form a right angle, and the angle that we make in the first quadrant is going to be 45 degrees. So remember, a reference angle is always between 0 and 90 degrees. It's never going to be bigger. It's never going to be smaller. So the reference angle is going to be always positive because it's going to reference to everything that's in the first quadrant. So these here are also called coterminal. Co means sharing. Terminal means that they are sharing the terminal side. So when they're looking at this part right here, that means they're sharing the terminal side. Co means that they are sharing. So in standard position, it starts here, it stops there, and then this one here starts here, goes this way and stops there. They're sharing the same thing. Why are coterminals so important? It's because they have the same trig ratio. And so when we look at this, the trig ratio right here is going to be, and if I do my left-hand rule with 45, I know this is the square root of 2 over 2, and this is also the square root of 2 over 2. The negative 315 and the positive 45 share the same coordinates, the y's and the x's. So if I know the 45, I also know everything about the negative 315. So when I go back here and I look at this, the cosine of negative 315, we have the trig function, we have the trig angle, And now it's asking for what is the trig ratio. That's the unknown. So the trig ratio here is cosine. So it's going to be the x value. So it's the square root of 2 over 2. Or you could do the left-hand rule of 45. And so again, trig function angle. So they're asking for the trig ratio. It's going to be the same. So if the reference angles and the standard position angles will always be coterminal, and so therefore we are going to start and end at the same position. So they're going to be have the same trig ratio. Okay, and then how do I fill this in? A terminal side of an angle theta in the standard position passes through -3, 4. So this is an actual coordinates. Remember, this is still standard x and y axes. So the point that we're looking for is -4. So we're going to go in the negative direction to -4, and then it's going to be +3 in the y axis. So we're looking at this point right there. So the point there is going to be -4 and 3. And so when I'm looking at this, I am going to draw a ray that is going to go from the standard position here to here, but I really don't care about that. All I care about is what's going to help me is my reference triangle. So my reference triangle, I know that this height right there is going to be a height of 3, and I know that this side right here is going to be a length of 4. Now, which one is positive? Well, the y values, this is in the y value is going to be positive. This one's going to be negative. The hypotenuse will always be positive because you're going to have leg squared plus leg squared is equal to hypotenuse squared. And no matter what, you're squaring everything, so you're always going to have a positive answer. And this one here is a reference triangle, which has a Pythagorean triple, so I know that this is 3, 4, 5 right there. So this is called a reference triangle. I don't care what this angle is. It's going to be less than 90 or bigger than 0, and it's in this quadrant. So I know that I could use that answers. So sine of theta is going to be, the leg is going to be opposite over hypotenuse. So I know this is going to be 3/5. The cosecant then I know is automatically 5 over 3. The cosine is adjacent over hypotenuse, so that's going to be -4/5. And then the secant is going to be also negative because they do the same thing as the secant. They're just reciprocals. And then tangent is going to be the two legs opposite over the -4. So that's going to be negative. And so therefore this one here as well is going to be negative because they're also reciprocals. Cosine is the x values. The x is going to be negative in that quadrant. So therefore we know it's going to be -4/5. Okay, so make sure that you know a couple of things. Also, one more last thing is knowing the signs on there. So if I have, and if you don't remember it, which you should, but let's say that you don't remember it, here's something that will help you. And this is going to be all. That means that they're all positive. All the trig functions are going to be positive. The trig ratios are all positive in the first quadrant. And then students, we're taking the s, so in this case here is going to be the sine, and the reciprocal is the cosecant, just like we saw up here that they're going to be the same sign. So sine and the cosecant, the sine of that angle and the cosecant are going to be positive, because then that makes sense because so the y values and this one is going to be positive. And then here is going to be take, and that's going to be the t. And then this one here, we know that tangent and the cotangent, therefore, are going to be positive. And then CAT, and that's the C. And then this is going to be the cosine of that angle, and therefore the secant of that angle are going to be positive. So all students take CAT means that all of the trig ratios are positive here. Here the sine is positive here, therefore the cosecant. T take tangent and therefore cotangent are positive, and CAT cosine and secant, and therefore that is positive. So there we go.